Hello everybody, and welcome to this explanatory video wherein the finer points of SuperElevation will be discussed and hopefully clarify for you that which you don't yet understand. In this example, we're going to refer to a right turning curve, 5% SuperElevation and 2% crossfall. Let's begin. How do we know this is a right turning curve? We know it's a right turning curve because the banking occurs on the left hand side. What is banking? It's when there is a rise. So as you can see on the left hand side, there is a change from minus to plus. That means that the ground is literally rising up. So therefore that's referred to as banking. In this case on the left hand side, therefore it's a right turning curve. Next aspect, we talk about crossfall. Crossfall is where one side will rise to 0 and then rise to maximum crossfall. In this example as discussed, we are using 2% and quite frankly it is the most commonly used example. And then the two terms called crown runoff and SuperElevation development are defined by two equations. So crown runoff over here is defined by Wessel, and SuperElevation development, this distance here, is defined by Wissel. Forgive my acronyms, but becomes necessary. Now SuperElevation development comprises of two bits, 2/3 length and 1/3 length. 1/3 of the length will sit in the circular curve. So when we are calculating information, we want to calculate a distance known as crown runoff. We want to calculate a distance known as SuperElevation development length, or L. And then we want to calculate 2/3 of L and 1/3 of L respectively. Why? So that we can calculate the necessary stake values. Very important. So there will be a stake value here. There will be a stake value here, and there will be a stake value here. What is significant about the stake value here? Well, it is where 2% crossfall, full crossfall has been achieved, i.e. 2% on the right and minus 2%, 2% plus 2% on the left and minus 2% on the right. So full crossfall has been achieved. So this distance is very significant. Now what is this distance? Well, outside of SuperElevation development, we've got crown runoff, and we have a reflective distance or a mirror distance within the SuperElevation development, which is also a crown runoff length. And that distance, that crown runoff length, defines banking from 0 to 2%, and outside it defines the banking from -2 to 0%. So very important distance. The SuperElevation development length, or L, as discussed, must be split into two bits: the bits outside the circular curve and the bit inside the circular curve. So once we've got these 1, 2, 3, 4 distances, we can calculate the stake values respectively. So why do we need these stake values? Because ultimately we want to calculate the centerline road levels at these specific points, and accordingly we want to then calculate the crossfall as well. Okay, so now to continue, we understand crossfall, and we understand crown runoff, and we understand SuperElevation development, but there are just a few other things that we want to just touch on. So once we have the 1/3 distance, we can calculate the stake values at the BC, or calculate from the BC. So from the BC to the end of this 1/3 of L, we've got a defining stake value here. This stake value is then the 5% full SuperElevation achieved. So basically this stake value, I'm gonna refer to it as maximum SuperElevation stake value, is the most important stake value. So anything past this point will enjoy 5% SuperElevation. But before this point, we've got to be able to calculate the changing SuperElevation between this stake value and this stake value here. So how do we do that? So let's just randomly pick a point. So I would have to know this random stake value here. So this stake value minus that stake value over this stake value and this stake value will give me the proportion. So a random distance here, I'd have to know the stake value, and that distance over this distance would give me a proportion, and then I'd be able to say that relationship multiplied by 3% will give me the percentage at this random point, and that percentage plus 2% will then give me whatever super elevation is happening here, and it will come up when you are calculating these very important points. So if there is something sitting here like a catchword or anything like that, and we need to know the detail, then you begin to see the purpose of calculating or being able to understand the methodology to calculate a random point here. So it would be stake value must be known, this distance over the full distance to give you the proportional relationship multiplied by the change in super elevation, which is 3% in this example. That answer will be, say, I don't know, 1.5%. 1.5 plus 2 is 3.5. So at that random point, the super elevation is 3.5%. So you can calculate your necessary road levels on the left and right of that point. Okay, I think we've covered everything that we need to cover. I thank you for your time, and I'll see you in the next calculation video.